Let's review some of the components of a neural network. There is the learning rate, which is the amount we change our weights during gradient descent. There's the number of layers that we have in our network, the number of neurons, what activation functions we decide to use. Not to mention, in order to train a model, we need a bunch of data. Sure seems like a lot of work. Wouldn't it be great if we didn't have to do all of it? The great news is that more and more teams and researchers are making their models readily available. Not only are there websites like Nvidia's GPU Cloud, where you can download ready-to-go models, but TensorFlow and PyTorch have modules within their frameworks to load a model into Python, given the model's URL. Keras itself comes with models prepackaged. Even better news? All of these models are free. The model we'll be experimenting with today is called VGG16, which was proposed in an appropriately titled paper, Very Deep Convolutional Neural Networks for Large-Scale Image Recognition. It was a winning architecture for the 2014 ImageNet Challenge. ImageNet is a database of millions of photos that have been labeled for thousands of categories, including animals, food, trees, sports, and people. Recently, these object detection models perform better than humans, having over a 95% accuracy. What better use for this model than to make an automated doggy door? We no longer need to get up in the middle of the night to let our pets out. Since ImageNet has many pictures of animals, we're going to use it to recognize our canine friends and keep all other critters out. After completing the doggy door, we're going to take on another challenge using an approach called transfer learning. Good news, everyone! The United States Secret Service has learned of our great machine learning skills and has contacted us to make a doggy door for the White House. To help us, they've given us a few pictures of Bo, the Portuguese water dog that serves as first dog from 2009 to 2017. We need to make sure this door only recognizes Bo and not any other dogs trying to sneak into the White House. The trouble is we can't use our pre-trained model because it can only recognize dogs in general. VGG16 can't tell the difference between Bo and other kinds of dogs. But if a model can already tell what a dog is, wouldn't it be great to use that as a starting point? It turns out we can. We just have to do a little bit of brain surgery to make it happen. Thankfully, the surgery we're doing on our machine learning models is a lot easier than actual brain surgery. We'll take a pre-trained model and essentially cut the end of it off. We'll use the top layer of the old model and then build out our new layers on the bottom. Technically, we can slice and dice these layers any way we want, but there's a practical reason for using the top of the model instead of the bottom. As we move from the beginning of our model to the end, from left to right in this case, our models go from more generalized to more specific. The top of the convolutional model picks up edges, and each layer builds on the last to build more complicated shapes. The more layers in the model, the more specialized those shapes are going to be based on the data it's trained on. These earlier patterns are easier to generalize. When it comes to transfer learning, it tends to be more useful to copy the building blocks found in the earlier layers. Another thing we should consider is whether or not we want to freeze the weights from the old model that we're building off of. Freezing is another way to say we're going to prevent the weights from updating during training, or to make them untrainable. Making the weights of the old model trainable can help specialize the new model for the new dataset coming in. But be warned, if the old model is large like VGG16, the higher number of weights will easily result in overfitting if the new dataset is too small. This would also be a good time to talk about data bias. Data bias is when a subset of our data is overrepresented. For instance, if we're looking to make a model that determines the manufacturer of a car, and we mostly have trucks in our dataset, our model will have a hard time identifying vans, sports cars, and sedans. This has come up frequently with discussions on the ethical use of artificial intelligence. If models are only trained on one ethnic group, then it can result in some embarrassing predictions in the underrepresented groups. This is something to think about when using transfer learning, as our new model can pick up the biases of the old model. To end on a fun note, transfer learning is a great opportunity to do something called dreaming. This is done by feeding an image through layers in our neural network, but instead of doing gradient descent, we're going to maximize our loss through gradient ascent. The goal is to exaggerate the patterns that the model sees in our image. Here, Bo has been fed through the first 3 convolutional layers from the Inception v3 model, and what we're seeing here are the gradients. As it progresses, the layers slowly start picking up more detail. Unfortunately, the full breakdown of the mechanisms would take more time than we have, but we've linked the tutorial on how to do it if you're up for the challenge. First things first, let's make our doggy door and our presidential doggy door.